Hi, my name is Abraham Gutierrez.
I'm Maurizio Altamura.
I'm Stephen Fadel.
I'm Xiaojin Dai.
I'm Zac Zimmerman.
And our mentor is Dr. Carolina Cruz-Neira, and our project is VR Sandbox.
So the VR Sandbox is a simple, fun, and interactive game that utilizes the technologies of VR to give players a fun and immersive creative outlet. The players can create, manipulate, and combine simple 3D objects in order to create a more complex build. To do this, we'll need to set up and accomplish a few goals. First, we need to create the immersive VR experience, and second, we'll need to give the players the tools in order to turn their imagination into a reality.
So the main objective of this project is an immersive and entertaining creative outlet. And the broader impacts that it has is the ability to build without physical limitations and a simple and viable alternative for basic physical modeling. And it's a fun alternative to building toys, such as Legos or Mego blocks for kids, and can stimulate STEM interest for young people.
We focus on testing our project manually with the help of our friends and family. We're testing the individual features before combining them. When features added to the main project, we do some regression testing to ensure no conflicts with previously implemented features. We do not perform any load testing since it's a single-player game. We try some testing based on our knowledge of the infrastructure of the project, where we randomly test out sequence of actions such as deletion followed by modification of another game object to see if any bug arise.
This is the start menu for our game. From here, we can select which scene to load into. We're going to go ahead and start with the space scene. So once we get into the scene, we can use the left thumb pad to move around. How this works is that the position of your thumb on the thumb pad is used to calculate the direction in which you're going to move. And then we use the right and left grips, and you can move up or down with these respectively. And then you can also press left or right on the thumb pad to rotate your camera 45 degrees. And so left will rotate your camera's angle by 45 degrees on the y-axis, and to the left, and then the right 45 degrees to the right. We can also move around the scene using the teleport functionality. So using the right thumb pad when we're outside of the menu, we can select where we want to teleport with the raycast and press down. So how this works is that the position of the raycast, if it detects a physical object at the end of the raycast, you can then teleport there and it'll move your character model to the corresponding spot. Now we can use the right menu button on top of the right thumb pad to open up our in-game menu. From here we can change scenes, save game, load game, go to settings, or quit game. So let's see all the scenes we have. So we have the forest scene, which is like some trees and some hills. And we also have our plain scene. And this is just going to be a basic wide open expanse for the user to build unobstructed. So now we're going to see some of the functionalities in the game. So we can go ahead and spawn an object by selecting one of these objects here in the menu, which we have 12 total objects. And then once we've selected it, we use the right thumb pad, and an invisible pointer will determine the position at the end of the raycast. And then this object will be spawned at the position of that pointer. That's how we determine where it's spawned. Then we can also delete these objects by pointing at the object and deleting it. Then we can change the length, width, or height, or all of these dimensions by selecting an object and then using the position of your thumb on the right thumb pad. It takes the magnitude on the y-axis and uses that as a multiplier to change the dimensions of the given object. You can also use the left controller on the left trigger and grab an object. When it's an interactive object, it's detected, which is the tag that we're giving these objects, and you hit the left trigger, an invisible pointer goes to the location of this object, and then this object gets updated so that its position is consistent with that of the pointer, and the pointer is a child of this controller. That way the object's rotation won't move, but its position will. Now we can also change the color of the object by using this color palette. The raycast will determine the position on the color palette, and it will grab the color at that specific pixel, and then we can use the right trigger to select that color for the object. We can then also copy this object by using the right trigger, and then we can respawn it. That way we can make duplicates of any objects if need be. Now, how the saving and loading works is we can save, and once we've saved, we can go ahead and load it back up. As you can see, it'll save the position, the color, the rotation. And so how this works is it uses a binary formatter to save the data into a file, but not all game objects are formatable into binary by default in Unity. So we have to use a serialization surrogate, which tells the binary formatter how to store the data for these game objects. And once we have that, then we can go ahead and save and load all the data from these objects into a file. And then that way we can load up creations such as this. Thank you.
While working on our project, we leveraged technologies such as Zoom and Discord for communication and Trello and GitHub for organizing our work. We also held weekly meetings to stay in touch with our teammates and our mentor.
So there were a few challenges that we faced as a group when we sought out to develop this project. Primarily, not all the team members had the necessary physical hardware to develop in VR. So in order to overcome this, we split tasks into two categories, those that could be completed without the headset and those that needed the headset. This way, everyone can contribute while maintaining a constant pace for deployment for features in every sprint.
Seeing our work start to become reality motivated our team to keep pushing to finish the project. And despite the initial challenges posed by COVID, we learned to stay in constant communication, which helped us keep on schedule and organize our work.
So since this is a student-created project, we did not have any stakeholders or a company we worked with. However, we had a virtual reality professional, our mentor, Carolina Cruz-Neira, and Professor Heinrich, who provided us with feedback throughout our journey. We took their feedback seriously, and it made our project higher quality and more industry formatted.
Our biggest lesson learned by working on the project is that solidified group tasks and organized workflow is essential for efficiency, and Agile is crucial for our project and work organization.
VR is a relatively new and growing industry, and developing a building game in virtual reality was something that was new, exciting for all of our team members. We got to learn about virtual reality development as well as game development, and we were able to create something that many people can enjoy.